So much for the very nice introduction of Core. Can you guys hear me? Can you guys hear? Yeah. Okay. So of course, just a brief introduction of myself. My name is Qiuchi, and I'm an assistant professor here at DIKU. So actually, it is this job match project that brought me here to Denmark, and also provided me the funding to be promoted to an assistant professor starting in the beginning of last year. Yeah. So basically, I'm as Core mentioned, I'm one participant of the job match project, and I'm basically in charge of the text generation part. But today I would like to present the whole scientific development, including both the job matching part and the text generation part, which is a pretty good case for using the machine learning as a solution for job matching. Yeah. So I think we need to first take a closer look at what problem we were trying to solve for the job match project. So basically we would like to take a closer look at what's happening there in the Jobindex recruiting workflow. Right. Suppose we have a recruiter, and he is faced with a job matching task, and he's presented with a job advert. So now he needs to type in his queries, maybe a couple of queries to interact with the search engine of the Jobindex, so that he can find all the relevant candidates fit for the job, and then he will write contact emails for each of those candidates. Of course, he usually has his own templates. So after that, he will just send those contact emails to the candidates saying, okay, we are interested in you because you have the right profile, you have the qualifications, so please consider applying for the job. So that's basically what's happening there. So, but what is this that we were trying to improve? So first, in the candidate search, basically the search engine in the Jobindex prior to the project was a little bit simple. It is basically a near exact string matching system where you can just type in a couple of keywords, and then it will automatically return the candidate CVs containing those keywords. So it's a very shallow matching. And also, it does not contain any deep semantic matching between the job and CVs. So for this reason, a recruiter would always interact with the search engine for multiple times before he really believed that he can find all the relevant candidates. So, and then in the contact emails writing stage, all the emails will be completely manually written by the recruiter. So in the rush hours, so recruiters would usually choose to basically write one single contact email to a group of candidates, which actually means that the email cannot go into the specific information of why the candidate is fit for the job. It will contain some general reasons saying, okay, we're interested in you because you have the right profile. So if you are there, so basically on the candidate sides, they would feel like they were basically reached out by a robot instead of a real person, and they would not be strongly motivated to apply for the job. So that's a problem that we had in the system. So on the recruiter side, they basically had a relatively low productivity due to the relatively simple search engine or searching algorithm, and also the quality of matching is sort of limited. And on the other hand, the candidates will not be that satisfied with the contact emails that were sent to them, right? So that's a problem that we are trying to solve here in the project. So that's why we have this project, because we want to improve this, and we want to rely on machine learning or AI models to provide a solution not only for the job matching part, but also for the email generation part. So first, we developed a deep semantic job CV matching model so that we can get a better matching between the semantics of the jobs and the semantics of the candidates, so that we can deliver a high quality first ranking result. So we would like to help the recruiters by providing a very accurate result, so that they don't need to spend additional time searching for additional candidates or typing in other queries. So the more relevant candidates appearing in the first result, the better. So on the other hand, we also developed an automatic algorithm for generating the contact emails, which should contain the personalized information. So it's automatic and it was personalized. So we built a model to learn to explain why a candidate is fit for the job by extracting information from the candidate's profile and also the job information. Right? That's also a typical machine learning scenario. So I will slightly introduce each of those two systems. I'm slightly moving the details of each of those two parts of the system. So first, in the deep semantic CV job matching, we built a transformer or BERT, which is a very typical building block for large language models as well, that allows us to encode the semantics of the jobs and CVs based on their texts. And on top of that, we can build a classifier, which tells us the probability of a job that is matched to a CV. So we have a large database that allows us to train a pretty good model that can allow us to predict the probability for any CV job pair in a pretty accurate manner. So after we have the model, when the job matching task arrives in the system, then it will automate. Then those relevant candidates will be ranked according to how they are similar to the job, and they will be used to produce the first rank results. Yeah. And for the neural generation model, basically what we did is to learn from the specific jobs and CVs that that match to each other to generate and personalize email in an automatic manner. So still we rely on the generative AI models with the similar building blocks as the large language models. But what we did is to extract relevant information. So we have a neural component that allows us to automatically learn which part of the qualification of the candidate is matched to the job, and feed that information together with the original job information to generate those case-specific fields of the email. As you can see in the email, those color tags are specific to the case, whereas the black tags are just the general template text. So what we actually do is to use this neural model, deep neural networks, to basically learn to generate those things, those color texts, right? So yeah, since we have limited time, I'll just be very brief about the result. But basically, we have achieved a very promising result with our matching model, where we can conclude that machine learning led to the overall success in matching, in terms of because by using our model, the neural matching model, we are able to help the recruiters identify more relevant candidates, and more importantly, the candidates are more willing to apply for the job. So basically that means that with the system, we are able to extract more candidates to apply for the job on average. So you can see the statistics there. I mean, all the measures, you can see a significant gap, between our new algorithms and the original ones. I won't go into details, but yeah, it's a huge success compared to the old system. But still, the quality of the generative emails, especially the specific those key components in the emails, there are still limitations in there. One issue that facing our model, as a generative AI model, is the hallucination issue. So it's still not able to get a very good prediction of the correct information in the CVs and jobs. So in many cases it's not a problem, but for this case where we need to make sure that the final contact email should contain the correct qualifications of candidates. So that is actually a big problem. So because of that, this generation model is still not integrated into the Jobindex workflow yet. But I would like to mention that we are on the right direction. But by comparing our model with the Llama model, we can see that we are able to have a higher average score in terms of the congruence with the CV compared to Llama. So that means it is because we have specifically designed a neural component that automatically extracts the part of the qualifications of a candidate that is fit for the job. Yeah, I think that's basically it. So just a very brief, brief introduction on, just brief take-home message. So data, is very important for machine learning applications or AI applications or large language models applications, and we also know that everybody knows that large language models has enormous power, but how to use that for our applications is still something that we need to investigate, especially in the job matching domain. So we have observed in our project the hallucination issue where it tends to generate some false information which could be fatal for some certain tasks. And beyond that, there's also this privacy issue where we probably need to make sure that there's no leakage of privacy information or personal information in the process of training a large language model, or in the process, or when the model is deployed to real applications. And there's also this fairness issue, which is happening because a model has its inherent bias, even for larger models, and that could lead potentially to unfair ranking results. For instance, it is it's always in favor of a specific group of candidates. So basically, we have a following project investigating the fairness of such models, which we call algorithm hiring. So which includes both models that we are working on and also the larger models. Yeah.
Your success criterion, I was kind of wondering, how would you know if your machine learning algorithm is just very good at picking out applicants that like writing a lot of applications?
Sorry, could you please
Well, if your algorithm find people that write a lot of applications, people that write few, maybe better motivated.
Yeah, exactly.
Then your success criterion would still be happy, right?
Yes, in principle, yes. So that's basically one issue, which is the fairness issue. So what we actually did is to, so where is that? It's actually compute or to do statistics on the average number of candidates that are actually contacting our job, that are contacting us with or without our new algorithm. So we basically use that to basically compare the two systems, sort of A/B test scenario, and basically use that to basically see whether our model leads to an success. But yes, I think you're making a very, very good point here, and this is.
You're working on a very hard problem. So.
Exactly. Thank you.